Hello, everybody. Good evening. Hope you're all having a fantastic day or night or whatever time or day it is when you watch this. Have I got a special treat for you? I kind of teased at this last time um, in my Minesweeper video that I had something special. Well, here's my special thing. It's Jarvis. It's not actually Jarvis. That's just what I named it, though. Um, Eventually, it'll be kind of like Jarvis. Um, this is a oh boy, how to even describe it? Um, this is a program that will use my webcam to capture my hand movement, and it will do that. And while it's doing that, it will identify the different points on my hand. Let me just show you. All right, I've got some proofs here. This is like the proof of concept, just to show like what's going on in the program. I'll give this a quick run through so that we can see what's going down. So it's going to turn on my webcam here. Oh, and there we go. So here we go, right? You can see my hand. That's pretty neat, isn't it? You can see all those nice little red points of data on it. Those are lost my train of thought. Little nodes with coordinate data. Each of them say, hey, I have this data at this point. That's what you can see here in this terminal, right? In this terminal here, when it's detected my hand, I'm going to put my hand up and you can see, oh, numbers, no numbers. And if we scroll up through it, they repeat themselves 1 through 20, or I guess 0 through 20. Those are the different nodes. Like each one has a different unique name to it. So I'm going to turn that off there. Uh, but let's go into the hand tracking, right? Let's actually no. I guess I'll stick in the proof. This proof explains like how it's working more so than that. So it goes through. It gets the capture using OpenCV, computer vision, and it uses the MediaPipe library from Google to detect my hands. It uses some kind of I believe it uses TensorFlow, Google's own neural network, to to analyze each picture of a hand that's fed into it by computer vision, and then it processes that information. Blah blah blah. That's boring stuff, though. I don't know how it does it. It's a neural network. Nobody knows how neural networks do their thing. Well, actually, no, they do, but they don't know how it gets to that point. That's part of the fun of that. The main program. I've got some antiquated code there, like that. There, I was going to use multiprocessing to try to make it so that like my hand tracker was running in one process and my mouse was running in the other process. Turns out that didn't work out too well, so I just kept the queue in, and because that's a nice little function there, a nice little class there, so it communicates between those two and says like, hey, here's this information, do this. Oh, mouse says thank you. Like in the hand tracking here, let me collapse everything just to get down to the update. So this is fed information into the update, right? So this is that same thing that I had just shown you earlier, right? So it reads the image and stores the image into itself, into this class, and then it flips it around so that it can properly say, like, tell left from right. And then it processes it, and then I have a function, right? So it takes those results, right? Some list of results. Actually, like, I don't even know what it is. Just a bunch of results, and then it sets them into this little function here, set hands. So set hands, um, it goes through, looks through the different hands, and right now I just have it doing stuff with the right hand. The left hand doesn't really do anything because I mean, it saves itself, but I don't process it past that for now. I'm going to do some stuff with it later on, but for now it just captures the right hand. But you see here, this captures the right hand information. This captures the left hand information, and everywhere else though I do just use the right hand. But keep in mind that it does differentiate between left and right hand. So it sets the results, and then it gets the gesture. It takes in some cue, and it sets the gesture. Okay, let's look at what's going on inside the gesture. So these are the different indexes, right? It looks through, okay, these points are located at these indexes. Indices? Dices, I don't know how to say it. Goes through, And okay, is there a classifier in the model? This is just a debug thing. Yes, this does have a classifier, and I'll go through the classifier in a little bit. If so, then set the finger position. Okay, that sets the finger position, which just says like, hey, which fingers are extended? This is like, this builds itself, and then it processes it in its little classifiers, and then it is set to either a 1 or a 0. Um, and this, okay, if the right index finger is extended and the right and the middle finger is not extended, that's its little pause, then it's not going to follow the pointer. Um, if the right index is down, then it detects a click, and then it's going to, oh look, I'm gonna go ahead and I'm gonna click. So it puts that in the self.point get pointer. It just passes itself, and it just says like, hey, which point do I want to track? That's kind of boring though. Back over to the mouse though. So it puts that information into the queue. Okay, looking over at the mouse, the update gets the queue, and it says, okay, what's this command? Is the command follow? If so, just going to move that to there. This is using the PyAuto GUI library, which is a pretty good library. However, this I think is the bottleneck of this point, because it takes a bit to process this information. I think it's surprising, right? Like once you look at like some of the other stuff that's going on, I was pretty surprised that that was apparently the holdup there. Um, and so here, looking at the commands, um, oh yeah, the right click is currently disabled just because it's not, oh actually no, in the hand tracker it's not going to right click just because I'm trying to figure out some queuing stuff where like, hey, yeah, I'm trying to work that code, but it does what I wanted to do, where it follows my finger and it is capable of clicking. So let's see this code in action. You saw the proof. Let's see it in action, and then I'll show you the neural network behind it. Right. All right. So you can't see my hand, unfortunately, but here I'm going to put my whole hand up. Okay, nothing's happening. Oh no, a little bit is happening. Oh, it's a little bit buggy sometimes. There we go. Okay, so I'm going to extend my first finger. There we go. Index finger is out, and I'm going to try to click. Come on. Click. There we go. It clicks. And then it clicks again. See, oh, okay, there we go. I was going to try to like do this whole entire video just using this as my mouse, but it's obvious that this isn't going to work. And you can see how jumpy this is. This isn't because it's not putting enough information into it. I mean, you can see here that its refresh rate is actually pretty quick. And when I tested it, it's actually the mouse that is the slower of the two. So I'm going to use my actual mouse here. I'm going to put that into there. I'm going to close that off. And then let's take a look at what's going on in that. Let me open up the where is it? Recognition test. All right, so this is using my latest model, my best model so far. Is going to open up the debug screen, quote unquote debug screen. So here we go. Hand is closed. It unfortunately cannot detect my thumb, so you can't see it, but I'm wiggling my thumb back and forth. It's not detecting my thumb yet. I haven't trained a model that can detect my thumb, but index up. See how nice that is? And this information is being fed into the mouse, but it's the mouse that's the bottleneck right now. Okay, so now, oh no, that's not my pinky up. There we go. My middle finger up, close them down. I said close them down. It's still a little bit buggy, I guess, when the processing's kind of skim. But if I put up, all right, so this is my whole hand extended. Again, you can see it's not detecting my thumb, but it's still pretty good. Still pretty good at predicting what's going on. This is me kind of waving my hand. You can see that, right? That's pretty good. So let's take a look at what's going on here. So I have a little trainer file here that just does a bunch of boring stuff. It processes data and sticks them inside of a CSV file with a bunch of information. This says like, oh, this is the state of all my stuff. Those are the coordinate points. Takes that information. I have a bunch of them I have a bunch of iterations that I had to go through. This is the one that I've settled on for my latest model. Um, um, and then it goes and, oh yeah, this one. This gesture classifier is broken. or at least it doesn't give me completely accurate data, so I rewrote it into this one, where it processes it and gives me 5. This one just gave me 1 for my whole entire hand. This one gives me 5 classifiers for my fingers, thumb, index, middle, ring, and pinky. And yes, when I was training this, I did unfortunately have to flip my computer off. I was very sorry, and I apologize to my compy. So please don't be angry at me for technology cruelty. Um, yeah, so neural networks are pretty complicated, so I'm not going to get into too much of that. But I do, so I initialize this little classifier. I tell it, like, hey, I want you to classify this data. This is just some data to, these are the neurons here. If you're interested in that, look up like neural networks. You can find out a lot of fascinating stuff about it. I'm telling it how many neurons are there. I have 45 inputs. I want it to go 500 layers wide, I guess. I don't want it to be very long. That's why it's only 4 layers long, but I do want it to go really deep, so that's why it goes 500 there, 250. But I ultimately want to wind up with 1 result at the end, so I'm giving it 1 neuron at the end there. And then I just tell it, hey, fit yourself, and it does it. Neural networks are pretty cool because they find little hidden connections between the data. Like, so I feed it this data, or let me show you the longest one that I've fed it. Right, this is like nearly 4,000 lines of my hand data. So I feed it this data, and it comes up with patterns, and it says, "Hey, I've noticed that if these points are like this, like here, let me go up to, what is this one? This one is just me pointing at it, right? So this is what, actually no, this is my thumb extended. Where's my finger? This is my finger pointing at. So that's my thumb, index, middle, blah blah blah. So it's saying, hey, if my index finger, information looks like this, right? This is my index row, right? No, that's my thumb. Here's my index. If my information looks something like this, then I think it's extended, and then it makes that connection, and then it tests itself with those connections over and over again until it comes up with something here. So if I want to show you guys like training my new data. So like if I wanted to get a new data set, because I always do, or a new set of data, which I always do, then what am I even saying? Data? No, I don't want new data. I already have data, and it hurts my hands to do that for so long. I want new classifier. So here we go. I'm going to run my little trainer, my little gesture classifier. Okay, so it prints off my data. It just says, hey, look, there's data there. And okay, this is for my thumb. This is the model for my thumb. It's not very good at predicting it. See, it even says there, ill-defined being set to 0 with no predicted samples. I don't want to save that, so I'm going to tell it, no, don't save that. Now it's going to rerun it. Still not very good. I'm going to rerun it till I see ones. I want these. These are percentages, really. I want as many ones as possible. Ooh, this one's pretty good. Okay, this one is very precise at detecting closed thumb. Pretty precise. I mean, like almost perfect at detecting open. Excellent at remembering both of those. It's pretty consistent throughout all of its tests, and it's got that many data samples that support its connection. So yeah, sure, I'll go ahead and I'll save that. So it saves that. Just this little gesture classifier right there. Oh, I don't like that. Let's retrain that. Oh no, I don't want that either. And this can sometimes take a while because sometimes it gets into like some pretty complicated models. Oh, I do like that one though, so we'll save that. But let's say I just want to stop there, so I'll just tell it skip. Come on. I could just Control C this and make it stop, but I don't want to. I don't want to do that. I want to show off my little skip button right there. See, if my input is skip, break. Ha, that's cool. Yeah, oh yeah, but how it does, so what these are actually pickled classes. Like these are not classes, objects. These are objects that have been pickled, or at least in JobLib's vernacular, it's just been dumped into some file. It's just been dumped into some file that's there. So after being dumped into there, I can then load it up. If I go back into hand tracking, what it does, so it says, hey, like, hey, where am I looking? I have a bunch of classifiers here. These are a bunch of old classifiers using that first program that turned out bum. These ones are the ones that I've been using. I have like little report files in there with like, oh, this one has like this digit that works. This is my most recent one though. This one works the best. Yeah, and you saw how well it worked. This works the best. It's training a good classifier is hard intensive work. Oh, and speaking of hard intensive work, this video is getting a little bit long. That's gonna kill my computer compiling it. Um, where was I going? Oh yeah. So if you go into the hand tracker, right? So just here in it, I tell it where to look, and it builds itself, and it says, okay, here, let's go ahead and load those dumped files in. So it goes and it loads in a file. It says, hey, I'm going to look in classification. So classification, individual classifiers, classifier 9 in this case, and then it's just going to select those 5 separate classes. That's for my thumb, index, middle, ring, and pinky finger. And then back to my, where did it go? Oh, I closed the tab. That's where it went. Hand tracking. So yeah, back here, yeah, so it goes through, it saves itself there, and then it uses those classifiers just like it does anywhere else, right? Just like it does in here. Yeah, in here. Except this time, instead of feeding it data that I already know, I'm feeding it data that I want it to predict, which is what you were seeing on recognition test there. So that's again, you saw that was working pretty nicely. So I'm super happy with how this turned out, even though it's not absolutely perfect. I'm still glad that I got to learn so much about neural networks and about like a bunch of cool other Python libraries. Like I knew about MediaPipe, like for example, that's the thing. I guess the major capture there. I knew about MediaPipe. I haven't really had too much experience with it though. And then I learned completely learned something new about like joblib and about pickling and dumping objects to use them again later on. That's pretty cool. Um, and then I learned a lot about like sklearn, about scikit, and like neural networks. So um, I might post a walkthrough. I mean, this is going to be in my GitHub, which is always in the description. So I might I'm going to come back to this and work on it. If anyone stumbles on this video and they have questions, shoot me a message wherever I can take messages. Yeah, cool. Well, thanks everyone for watching. Don't forget to smash that like and subscribe button. Blow it up, demolish it. I don't want to see it anymore. And support me on Patreon. I don't have a Patreon, but if you find the secret Patreon, you will win the golden ticket to my chocolate factory. Anyways, have a good one.